In this section, we're going to look at how to multiply two complex numbers together. In order to be able to do that, we're going to have to know powers of I. So let's think about some powers of I. I to the power of 1 is just the square root of minus 1, which we normally just write as I. I squared is minus 1. I cubed, well, we could write I cubed as I squared times by I. But we know that I squared is minus 1. So we've got minus I. Minus 1 times I is minus I. And I to the power of 4 is I cubed times I. But we know I cubed is minus I. So that's minus I times by I. I times I is I squared, so we could write that as minus I squared. But we know that I squared is minus 1. So we've got minus 1, which is 1. Now, what we're going to realise is actually this cycle of I minus 1 minus I and 1 repeats. And you should see why in a second. If we've got I to the power of 5, we could write that as I to the power of 4 times by I. I to the power of 4 is 1, so we can just write that as I. Similarly, I to the power of 6 is I to the power of 4 times I squared. So that's just I squared, which is minus 1, because I to the power of 4 is 1. I to the power of 7, again, we can take out a factor of I to the power of 4 times by I to the power of 3. I to the power of 4 is just 1, so we get I to the power of 3, which we know is minus I from before. And I to the power of 8 is I to the power of 4 times I to the power of 4. I to the power of 4 and I to the power of 4 is 1 times 1, which is just 1. So you can see that this cycle of I minus 1 minus I1 repeats itself in blocks of 4. So we can work out some slightly more complicated powers of I using what we've just done here. Let's think about I to the power of 16. Well, 16 is a multiple of 4, and we know that every multiple of 4 as a power of I is 1. So actually we know that this is just going to be equal to 1. If you're not happy about that, you could write that as I to the power of 4 to the power of 4, because 4 times 4 is 16. And I to the power of 4 is just 1, so we've got 1 to the power of 4, which is 1. Similarly, if we had I to the power of 100, we know that that's I to the power of 4 to the power of 25, because 25 times 4 is 100. And I to the power of 4 is 1, so 1 to the power of 25 is just 1. So we know that that's 1, because that's a multiple of 4. So we could work out some slightly more complicated powers. Let's think about I to the power of 13. Well, what we do to work out a more complicated power like 13 is we think of what's the highest number, what's the highest multiple of 4 that goes into 13? And that's 12. So we could write that as I to the power of 12 multiplied by I. Well, because 12 is a multiple of 4, we know that I to the power of 12 is just 1. Or if you prefer, you can use the fact that I to the power of 12 is I to the power of 4 to the power of 3. So that's 1 to the power of 3, which is just 1. So we know that this is the same as I, because it's 1 times I. If we add I to the power of 66, we've got to work out what's the biggest multiple of 4 that goes into 66. And that's 64. So we're going to write that as I to the power of 64 times I squared. 64 is a multiple of 4, so this is just 1. So we just end up with I squared, but we know I squared can be simplified to minus 1. So in example 5, we're multiplying two complex numbers together. So to multiply two complex numbers together, we're just going to treat I just like any other algebraic constant. So in part A, we're just going to expand this bracket to get 8 plus 10i plus 12i plus 3i times 5i is 15i squared. And we want it in this form a plus bi, which is the normal form of writing a complex number. So before we do that, we're going to simplify the powers of I. So let's simplify I squared. Well, we know that I squared is equal to minus 1. So I'm going to replace I squared with minus 1. So that's 15 times minus 1, which is minus 15. Then we're going to collect together the real parts without I in it. So we've got 8 minus 15, which is minus 7. And we've got 10i plus 12i, which is plus 22i. So we've got it in that form, real part plus the imaginary part times by I. In part B, we're going to do a very similar thing, and we're just going to expand the double bracket. So let's do that. We've got 49 minus 28i and minus 28i, and then we've got minus 4i times minus 4i. So I'm going to do minus 4 times minus 4, which is 16, and I times I, which is I squared. So plus 16i squared. I wouldn't recommend jumping the next step all in one go. I would write out the I squared term before replacing I squared with minus 1. So that's what we're going to do on the next step. We're going to collect together minus 28i minus 28i is minus 56i. And I'm going to replace I squared with minus 1. So here we get plus 16 times minus 1, which is minus 16. And then finally, I'm going to collect together the real parts without I in it. So 49 minus 16 gives me 33 and minus 56i.